Hey guys, welcome back. In our last lesson, we learned about empirical formulas, and today we are going to be talking about molecular formulas. So as with everything in this unit, if you haven't done your previous lessons, you need to do that first, and you need to do them in order, because if you haven't, this will make no sense. So with that in mind, let's go ahead and get started today. So yesterday we talked about our empirical formulas. So we learned how to take the percent composition of a compound and convert it into its simplest form. So for example, one of the examples we used was carbon dioxide, which was 27.29% carbon, 72.71% oxygen. When we do the empirical formula, remember we calculate the moles and then we divide by the lowest number of moles to get the number of atoms of each of the elements in the compound. So the simplest form was CO2. Now, today we're going to learn how to go from our empirical formula to our molecular formula. The molecular formula is going to be a multiple of the chemical formula. So whereas the empirical formula is going to be the simplest form, molecular formulas are not necessarily in the simplest form, meaning that normally when we get to the end of a compound, if it's divisible by a common factor, we do that. That will not be the case with our molecular formulas. Basically, they're just the formulas that are not in the simplest form. Okay, so for example, the molecular formula of CO2 would be C2O4. So, our initial gut reaction here when we see this is, oh, 2 and 4 are divisible by 2, so that can be simplified. But again, when we're calculating molecular formulas, they will not necessarily be the most simple version. Okay, so we're going to have to kind of break that habit here in order to do these correctly. Okay, so let's take a look at the steps for how to calculate molecular formula. So here's a problem we'll be working through. The empirical formula of a compound is C3H5O2. The molecular mass is 146.16 grams per mole. What is the molecular formula? Okay, so we have molar mass here and we have our formula of our compound. So this is going to be the empirical formula. So this means this is the simplest form. We basically want to find the molecular formula, which is not the simplest form. So let's see the steps of how to do that. One, we're going to determine the empirical formula if not already given. So in a lot of these problems, you'll already be given the empirical formula, but if not, you're going to have to determine it. And that you're going to have to use the steps that we learned in yesterday's lesson. Okay, so you have to make sure you know how to calculate empirical formula first before you can do molecular formula. To make things easy, on a lot of your quizzes and tests, you will already be given the empirical formula so that you don't have to do all the extra steps. Step 2, you'll have to calculate the molar mass of the empirical formula. So again, we're going to have to use our average atomic mass for each of these atoms in order to calculate the entire molar mass. And then you're going to divide the molecular mass given by the empirical molecular mass. Okay, so that means you're going to take the molar mass of the molecular formula and divide it by the molar mass of the empirical formula. So another fractional problem. So our molecular formula, or our N, is going to be our molar mass of our molecular divided by the molar mass of the empirical. Okay. And then we're going to multiply that empirical formula by that value of N. Okay. So for example here, so like in this problem, it says the empirical formula is C3H5O2, molecular mass is 146.16. This is going to be the number on top, okay? So we'll have to calculate the molar mass of the empirical formula, so we'll have to calculate this, and then we'll divide 146.16 by the molar mass of our compound, okay? So let's take a look and see what that looks like. So C3H5O2, the first thing we have to do is get the molar mass, right? That's going to come from your periodic table. So you're going to need 3 carbons, 5 hydrogens, and 2 oxygens. And remember, when we're calculating molar mass, we have to go to the table and we have to get the average atomic mass. So it'll be 3 times the average atomic mass of carbon, 5 times the average atomic mass of hydrogen, and 2 times the average atomic mass from oxygen, all coming from the periodic table. Okay? So 3 times 12.01, again that 12.01 is coming from the table, will give us 36.03 grams. 5 times 1.01 will give us 5.05. Again, the 1.01 is coming from the average atomic mass. You have to use your periodic table. And then 2 times 16 gives us 32 grams. Again, the 16 is coming from that average atomic mass on the table. So we're going to add all those up. 36.03, 5.05, 32 will give us 73.08 grams. Okay, so the molar mass of the empirical formula is 73.08 grams. The molar mass of the molecular formula is 146.16 grams. And again, that will be given to you in the problem. Okay, the only thing you'll have to calculate is the empirical formula molecular mass. Okay, so now let's calculate N. So N is going to be the mass of the molecular formula divided by the mass of the empirical formula. So 146.16 divided by 73.08. And it makes sense because we know that the molecular formula is going to be a multiple, so the mass of the molecular formula should be larger. So that will give us 2. Okay, so our N value is 2. So we're going to take everything, our subscripts, and we're going to multiply those by 2 to get our molecular formula. So here we are multiplying the subscripts. This is not, we're not adding it as a coefficient. We are multiplying the subscripts by that value. So C6, 3 times 2 is 6, 5 times 2 is 10, 2 times 2 is 4. So our molecular formula is C6H10O4. Okay? And again, with these, it's really great in your notebook to have the steps and the example. So you can follow step by step, especially when you're doing them on your own, you can have the example right in front of you. Okay? So let's do one more example. Automobile antifreeze is composed of 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen. The molar mass of this compound is 62.1 grams per mole. Determine the empirical and the molecular formulas. So here's an example of a problem that would take you a little bit longer to work because the empirical formula is not given to you. So you're going to have to do the steps from yesterday's lesson first and then do the steps from today's lesson. Okay? So again, we're going to determine our empirical formula, calculate the molar mass of our empirical formula. We're going to divide our molecular formula weight by our empirical formula weight, or mass, and then we're going to multiply that empirical formula by that N value. All right, so let's do the empirical formula first. So we have CH3O. We have to find the molar mass. Okay. And again, this molar mass is coming from the empirical formula. This CH3O you would have to calculate. Okay, so we're assuming that we have calculated the empirical formula. So in that last one, we were given the percentages, and then you would have to calculate this empirical formula from those percentages. So if you don't remember how to do that, you need to go back and look at yesterday's lesson. So now that we have our empirical formula, we have that CH3O, we need to make sure we calculate our molar mass of our empirical formula. So we have 1 carbon, so we would do 1 times 12.01, which again comes from the average atomic mass on the table. 3 hydrogen times 1.01, And then we have 1 oxygen, which is 16 grams. Again, all of these numbers in parentheses come from the average atomic mass on the table. And I know I say that over and over again, but it just seems to be the place where students get tripped up, which is finding the molar mass. So let's add these up. So 12.01 plus 3.03 plus 16 will give us 31.04 grams. So this is the molecular mass of our empirical formula. Okay, the mass of our molecular formula is 62.1. So we're going to divide that 62.1 by 31.04. Okay, so 62.1 divided by 31.04 will give us an N value of 2. Okay, our final step is to multiply each of these subscripts by that 2 value. So the 1 times 2 will be 2. 3 times 2 will become 6. That says 16, it should be 6. And then 1 times 2 is 2. So it should be C2H6O2. And that's just a typo in the slides. I'll go back and fix that. But it should be C2H6O2. Okay. So again, if you got lost, and I didn't want this video to be extremely long, so I'm assuming we know how to calculate empirical formula. If you don't know how to get from the percentages in this problem, so from the percentages to the empirical formula, please go back into your previous lesson and make sure you know how to do that, because you do have to, in some instances, calculate your empirical formula first. Okay? If you have any questions, let me know. Again, these are going to be practice, 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 and it's just making sure you have your steps written in your notebook so that you can follow them to a T. Okay, if you need any extra help or some tutoring, let me know, and if not, I will catch you in that next lesson.